Welcome back. This is the third lesson recording for IM1, May 14th, 2021. Are the triangles congruent? If yes, what rule? Let's look at the information we're given. We're given one pair of congruent angles, that's the green arc, and one pair of sides that are congruent, that's the two blue notches, and another pair of sides that are congruent. That's the orange notches. So we have an angle and a side that are congruent pairs. Okay, notice that the angle pair that is congruent is not in between the two sides that are congruent. So it's not the included side or included angle. So instead, to go in one direction, we say this is angle, side, side, and angle, side, side. What does that spell? ASS. Oh, that's a bad word. We don't say that in math class or in any class, right? Well, this is one class, one day, or maybe this unit is the time that you can say that word in math class. Okay, ASS is not a congruence theorem. Why is that? Or congruence shortcut. Why is that? Because when I have angle side side, I can actually create two different triangles. And let me just show you the possibility. This has the same side. Okay, this is the same length. I've just copied it and then tilted it over. Look at that. Okay, so I am using the same angle, same side, and another same side. Okay, but I have just created two different looking triangles. If you can create two different looking triangles from one given angle and two sides, then we can't use that. It's not always going to be true. So we cannot use ASS as a congruence shortcut. Okay, so you need to really make sure that the angle pair that you have that are congruent is included angle. If that is the case, then that becomes side, angle, side. That is a congruence shortcut. But if it's angle, side, side, if it's not an included angle here, then that spells ASS, and that's a bad word, and that is not a congruent shortcut. And so if you ever tell me that ASS is a congruent shortcut, I am going to throw a donkey at you. E-oh. Okay, and because ASS is a donkey theorem, we don't have that as a shortcut for congruence. So please remember that. Whenever you see an ASS, think about a donkey, and we don't say donkey theorem in math class, and because donkey theorem is not a congruence shortcut. So let's get back to the decimals, and we're just going to try to cover as much as we can the rest of the period. Okay, which triangle is different to the others? Okay, looking at this time we don't have notations, but we are given side length. We have 3, 4.5, and 2.5. We have 3, 2, and 4. No, 3, 2, and 4. Which two which triangle is different? Well, these two are congruent because we have 3, 2, 4, 3, 2, 4, but this one is way different, right? Okay, so which rule shows the remaining two triangles are congruent? Possible rules are side, 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 angle, side, ASA or AAS. Which do you think is correct? Well, we have a side, one pair that is congruent, and another pair of side, and another pair of side that are congruent. So this is going to be side, side, side. Which triangle is different to the other triangles? Okay, so we have 32, 6, and 58. 34, 6, and 58. 32, 6, and 58. We have 32, 6, and 58 here, and 32, 6, and 58 here. So the different one is this one. Okay, so looking at these two triangles that are congruent, which rule? Okay, so we have one pair of angles that are congruent, 32 and 32, and another pair of angle that are congruent, 58, 58, and the side length 6 and 6, those are the side length, they are congruent, and that side is in between the two angles that are congruent. So this is going to be angle, side, angle. So it is angle, side, angle. Alright, then what about this? Side, side, side congruence. Click on the image with the congruent triangle because of side, side, side rule. Side, side, side rule means we need three sides, three pairs of sides that are congruent. Okay, so here I have one pair and two pair. That's not enough. I have one pair that are congruent. I need all three pairs. So I have one pair here, two pair here, and three pair here. So that will be the middle one. Okay, click on the image with congruent triangles because of SAS rule. Okay, so that means we have two sides that are congruent, and the angle, do you see the angle is in between? We need that angle that are the angle pair that is congruent to be in between the two side pairs that are congruent. Okay, so here we have two angles. We don't want that. Okay, here we have two angles again. Okay, we don't want that. We need two sides. I have one pair of side here and another pair of side here. And the angle that are congruent is in between the two sides that are congruent. Two sides. So it's this one. Alright, so mark the sides which must be congruent to prove that triangle congruence triangles are congruent by SASA. Okay, ASA means we need two angles and the side in between. Okay, two angles and the side in between. So I have one pair of angle here and another pair of angle pair. Okay, and I need the side in between to be congruent. So between this angle and another angle, the side that we're congruent, it will be this, right? What about this? I have one pair of angle here, another pair of angle here. Okay, so one pair and another pair. So I need the side that are in between like that. Okay, this, check your work from slide. It says slide 19, but it should be from previous slide, slide 12. Okay, the slides you should have marked as congruent are marked in red. And we got that, so we can move on. Alright, mark the angles which must be congruent in order to prove the triangle is congruent by SAS. This time we should have two pairs of sides that are congruent, and the angle in between those two sides should be congruent. So we need two pairs of sides. We have one pair here with one notch and one notch, and second pair of sides that are congruent, and we need the angle in between. Which is the angle in between? So this is the side here and this is side here. The angle in between is this, and the angle in between is this. What about this? I have one pair of the side and I have another second pair of the side that are congruent. So which is the angle in between those two lines? It's this one and this one. Alright, check your work from the previous slide, and the angle should have the marking. Okay, and you can certainly read this. Alright, which triangle is different to the other? Okay, so now this time we have 4 centimeters, 2 centimeters, and 30 degrees. 2, 4, 5, 2, 4, 5. Okay, I have 2, 4, 5 and 2, 4, 5. We're actually given more information about this angle. Okay, so I know that 2, 4, 5, 2, 4, 5. I know the sides are the same between these two. So they satisfy the side, side, side rule. Okay, let me just double check with this. We have angle 30 degrees, and we have 4 here, 4 here, and 4 here, and 30 degrees, 30 degrees. So if this side matches up with this side, then they are congruent. But we have 2 centimeters and 5 centimeters, so these two are not. Whereas these two are congruent. Oops, no, this is the different one. Okay, so and for the other two triangle, which is the congruence shortcut that we can use, it is SSS. Click the image with congruent triangles because of AAS rule. Okay, so we are looking for angle, angle, and side. So angle, angle, side means I have two angle pairs that are congruent, and the side that is not in between those two angles, so it is not the included angle, it's the side that is outside. Okay, so I have angle here, and another side, and that side is not in between the two angle pairs that are congruent, so this would work. What about the other one? This here, we have one pair of congruent triangle angles and another pair, but it is an included angle. This will be ASA, and this will be angle, angle, angle. So the correct one is this one. All right, so now you get to move the triangle. It's a card sort. So we have not congruent, ASS. No, we don't have ASS. AAS, SSS, and ASA. Okay, so what do we have here? We have side, angle, and side. We have two sides and an included angle, so it's going to be side, angle, side. What do we have here? We have side and a side and a side and a side. Is that enough information? No, we need at least three things. Okay, so that's not congruent. What do we have here? We have angle, angle, and the side. We have angle, angle, and the side. Angle, angle, and side. So angle ASS. Oops. Let me just bring them out so that what do we have here? We have one pair of sides that are congruent, another pair of sides congruent, and third side of pairs that are congruent, so it's side, side, side. What about this? We have angle and another pair of angle with in between the sides that are congruent, so it's angle, side, and angle. So angle, side, and angle. All right, we have, what do we have here? One pair of angle, another pair of angle, and third pair of angle. Angle, angle, angle. Is angle, angle, angle a congruent statement? No, it's not. So it goes in the not congruent category. All right, so we just have two more. Oops. All right, so here we have one pair of side, two pair of side, and a third pair of side that are congruent, so it's side, side, side. What about this? We have one pair of angle and another pair of sides. So we just have two things. Two things are never enough. Okay, so that's the card sort. Okay, so we have 13 of 13 correct, and the next cards is just for fun for you to be playing around to make a square, or okay, so if I was to make a square, how can I move this to make a square? And I can tilt this using those red dots, and voila, that's my square. See if you can find trapezoid. What is a trapezoid? Trapezoid would look like this, or this. Okay, so we have parallel lines and the sides that are not congruent. Okay, all right, that's it for today. So what did we do today? We worked on triangle shortcuts that side, 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 angle, side A, angle, and angle, angle S, side, and side, angle, side are the only congruence shortcut that you can use, and that's the only information you need. If it's anything other than that, the triangles are not congruent. And for homework, you're going to be working on tessellation project to finish that. Thank you for listening.